Section 3.7, Derivatives of Logarithmic Functions. In this section, we use implicit differentiation to find the derivatives of the logarithmic functions y, which is equal to the log of base a x, and in particular, the natural logarithmic function y is equal to the natural log of x. It can be proved that logarithmic functions are differentiable. This is certainly plausible from their graphs. So let's go ahead and then take a look at the function where y is equal to the log of base a x. Okay, so what we want to do is we want to rewrite this in terms of an exponential form. So the exponential form tells us that we have a base of a that has an exponent of y, and then that's equal to x. Okay, now what we want to do is we want to be able to differentiate. And we're going to differentiate implicitly. Okay, so if we look at this function ay equal to the x, well, we know that we have a to the y times the derivative of a to the y, which is going to be the natural log of a times y prime, and that's going to equal the derivative of x, which is 1. Okay, so now that we have ay times the natural log of a times y prime, and that's equal to 1. And so what we want to do is we want to be able to solve for y prime. So let's go ahead and solve for y prime. So we're going to divide both sides by a to the y times the natural log of a to the y times the natural log of a. So therefore, we can see that y prime is going to equal 1 over a to the y times the natural log of a. Now let's go back to what a to the y equals in our problem. Well, we can see here that a to the y is equal to x. So we're going to replace this a to the y to be the value of x. So therefore, we can say that y prime is equal to 1 over x times the natural log of a. So what this does is this gives us our first definition. So the first definition tells us that the derivative with respect to x of the natural log of base ax is going to equal 1 over the value of x times the natural log of the base a. Now, if we put a, which is equal to e in Formula 1, and then the factor natural log of a on the right-hand side becomes the natural log of e, which is equal to 1, then we get the formula for the derivative of the natural logarithmic function, the log of base ex, which is going to equal the natural log of x. So that gives us definition number 2. Definition number 2 tells us that the derivative with respect to x of the natural log of x is going to equal 1 over x. Now, by comparing formulas 1 and 2, we see one of the main reasons that natural logarithms, logarithms with base e, are used in calculus. The differentiation formula is simplest when a is equal to e, because the natural log of e is going to equal 1.